Yeah, good morning to one and all. Myself Himat Kumar, Assistant Professor, Department of Civil Engineering. So our course is Advanced Design of Reinforced Concrete Structures with course code 21CE3221. It is coming under cohort E28 Structural Engineering. So coming forward, today's topic is about chapter 9, that is nothing but design examples for deep beams. So coming for what is meant by transfer beams. So transfer beams are deep structural elements used to transfer loads from one area of the building to another. They are typically employed in multi-storied buildings where they enable the creation of open spaces by redirecting the loads from upper floors to the lower floors. These beams are designed to effectively distribute the concentrated loads from columns or walls to the supporting elements, ensuring stability and safety. So coming for the next one is about the what are meant by corbel beams. So corbel beams are deep beams designed to provide support for concentrated loads, often in case where a vertical load needs to be carried out by horizontal member. Common applications include supporting heavy equipment or walls on top of the columns. The design of corbel beams must consider the load magnitude as well as the load distribution and the potential stress concentration. So this is about just the general introduction about the transfer beams as well as the corbel beams. So coming for the next one is the bridge piers. So in bridge construction, deep beams are used as piers or abutments to support the superstructure of the bridge. These deep beams transfer the loads from the bridge deck to the foundation. The design of the bridge piers is critical to ensure that they can withstand the dynamic loads and environmental factors specific to their location. Coming for the next one is the underground structures. So deep beams are integral in the design of underground structures such as tunnels, underground parking garages and basements. So they serve to support the weight of the structure above as well as any live loads within the underground space. Proper design and reinforcement are essential to maintain structural integrity and prevent deflection of failure. And coming for the next one is about the foundation beams. So foundation beams are often used in industrial plants and warehouses to support heavy equipment, machinery and storage loads. These deep beams distribute the concentrated loads and ensure that the foundation remains stable under heavy point loads. Shear walls. Deep beams may be part of shear walls which are designed to resist lateral forces like wind or seismic forces. Deep beams within shear walls play a crucial role in distributing these lateral forces throughout the structure and providing the stability to the structures. Coming for what are meant by retaining walls. Deep beams in retaining walls, where deep beams are used. Deep beams are used to reinforce retaining walls. They are designed to retain earth and resist soil pressure. The beams distribute the pressure from the retained soil and enhance the structural integrity of the wall, preventing bulging or failure. So coming for the next one is the underground parking garages. So deep beams in underground parking garages bear the weight of the vehicles, pedestrians and the structure above. They must be designed to withstand dynamic load from vehicles and ensure that garage remains safe and functional. Coming for next, water tanks and silos. Deep beams are utilized in the support structures for water tanks and silos. These beams ensure that the structures can safely carry the weight of the stored materials and withstand the environmental forces that are coming onto the water tanks as well as the silos. Next one is aircraft hangars. So in the construction of aircraft hangars, deep beams are employed to support the roof and handle the substantial loads imposed by large and heavy aircraft. So the design of these beams is critical to ensure the safety of the structure and the aircraft housed within. So in all these applications, deep beams are subjected to various loadings including the dead loads, live loads, dynamic loads as well as the environmental forces. So here environmental forces, in a sense, it may come sometimes that may be due to the earth pressure, due to the air due to the water or due to the climatic conditions. All these things may be coming into the picture. So engineers meticulously calculate and design these beams to meet structural requirements and adhere to built codes and safety standards, ensuring the overall stability and safety of the structure they support. So coming for what are going to happen in this is definition of the deep beams. To understand and define the concept of the deep beams in structural engineering, including the characteristics and applications, and identify the common applications which are used in civil engineering aspect. So next, explanation about the load distribution. To explain how do deep beams distribute loads in different structural scenarios, including transfer beams, corbel beams and bridge piers, and describe about design considerations when working with deep beams, such as load factors, material properties and deflection limits, and to understand the structural stability in maintaining the structural stability and safety of the buildings and other structures, and to analyze real world examples of deep beam applications, including their role in underground structures, retaining walls and foundation systems. And also next, to calculate the load distribution and perform structural analysis for deep beams in various scenarios, considering both static and dynamic loads, and complying with the building codes. So the design should comply with relevant building codes, standards and safety regulations to maintain the structural integrity, and also to apply the engineering principles such as stress analysis, load bearing capacity and material section in the design analysis of deep beams. And coming for the next one is about the problem solving skills to address complex structural challenges related to deep beams and propose effective solutions to improve structural performance, cost effectiveness and sustainability, to understand the successes, challenges and lessons learned in real world problems, to know the importance of safety and durability in deep beam design to prevent structural failures and ensure long time reliability. So I am stopping up to here. So we will see the next things in the next presentation. Thank you.